This is the James Webb Space Telescope. It is one of the most advanced space telescopes ever built, and it was designed to look at some of the earliest stars that formed just after the Big Bang. On Christmas Day 2021, the James Webb launched from the Guiana Space Center in French Guiana, where it began its month-long journey to its new home in space, the L2 Lagrange Point.
Several telescopes have gone to, including the James Webb Space Telescope, is the second Lagrange point. And there, basically, the sun and the Earth and the satellite are all in a line. And effectively, you get the gravitational force of the sun plus a little bit of extra from Earth. And so what that does is it means that there's a 1-year orbit where you can stay at this point and always be in line with the sun, the Earth, and the Lagrangian point.
In the early 1990s, the National Aeronautics and Space Administration, NASA, began planning for the telescope that would replace the Hubble Space Telescope. In 2004, the European Space Agency joined the project, followed by the Canadian Space Agency in 2007. Bringing the James Webb Telescope to life was no easy task. This was going to be the most complex space telescope ever created. The project faced delays and cost overruns. There was even a major redesign in 2005. On November 2016, construction of the telescope was completed and ready to be launched to its new home at the L2 Lagrange Point, some 932,000 miles away. When the James Webb Telescope arrives, it doesn't exactly stay at the L2 Lagrange Point. Instead, it orbits around that point.
So what's special about it is you can always keep the sun, the Earth, and your satellite in the line. The reason that several telescopes, including Webb, are there is it allows you to have a stable orbit where you're kind of close to the Earth so you can do your communications, but you don't have to go around the Earth. So with the Hubble Space Telescope, when we're trying to look at planets, there's a challenge. You start looking at a planet, then you have to go behind the Earth, and you get interrupted, and then you come back, and then you can observe it, and then you get interrupted. When you look at a planet, or you look at something, try to measure it really finely and stably, you're getting interruptions to your observations.
After months of testing and calibrating the telescope's mirrors and instruments, the world finally got to see the telescope's full-color images and spectroscopic data. These images show stars being born and ripped apart, images of stars previously unseen, because they were cloaked by dust, and spectra showing the atmospheric composition of a hot gas exoplanet.
We're not going to answer, life, big question, are we alone in the universe? Might not even be answered by Webb at all, but we're trying to get closer to that. That's a big driver for many of us in the planet fields. One thing, we look at planets, in the solar system, we have these terrestrial sized bodies, and we got the gas giants, ice giants. We don't have anything in between. But we know that there are lots and lots of planets out there. They're in between the what we have in the solar system, the terrestrial and ice and gas giants. So there's these new kinds there's called sub-Neptunes and super-Earths. So we're going to try to get spectra. So far, very little is known about these planets, and whether they're steam atmospheres or very puffy atmospheres with a big rock in the middle. And we're going to start to learn that about those in the next year.
As the James Webb looks out into space, this incredibly powerful instrument will peer into the edge of the cosmos and view some of the most distant galaxies ever seen and some of the first stars being formed. The telescope will also capture light that filters through a planet's atmosphere and detect its faint chemical signatures. As we look out, James Webb will change the way we see our own solar system, the galaxy we live in, and our universe.
Mountain, I'm counting at least 200